Hello guys and welcome back. So I did a preview of the sim and this is how it looks like. I'm actually pretty happy with the result. I think for everything is working as expected as long as there is no explosion or pieces are flying off. Everything looks stable to me, and maybe these guys are spinning too fast so we can add a pop spin limit. But other than that, I think it's working pretty well. Now I went ahead and tweaked the settings back, and nothing really fancy. I changed this from 20,000 I think to 80,000. I turned on the glue constraint that holds the pieces together. The pin constraint break-in rule is 32,000, and the angle is 20. And this is the result after that. So again, we're gonna lose this result. So this is how it looks like. Everything is basically getting destroyed. Let's do this. Not a great angle. Let me change this. Come on. So this is the new result playing. It's running the play now, and as you can see, we're just changing 2 or 3 values. We're getting the behavior that we want, and primarily what I'm looking for is the clustering to be there and the multi-fracturing behavior to be there as well. And the fact that we have this big block falling and still packed together is very, very cool. I see that when it hit, it bounced. It didn't just break and stuff like that. So there's a nice fluid motion going. And this is all the secondary fracturing as well, which is great. Cool. So let's continue. I'm gonna briefly explain wood fracturing, which is pretty simple. So let's say we have some planks like that. Let's copy them. Okay, and I'm gonna use a BDB from Polygon, scatter some points, and what I'm going to do is I'm going to transform this along the vector that the plank is going to, and I'm going to, let's generate the points based on that. Do 300, and then I'm gonna copy, create reference copy of this, and then let's run the Voronoi fracture with the result deformed like that. So we fracture them when they're compact. Let's do 800, and then we're gonna stretch this back, restore the transformation. So I copied the transform, and then we're going to turn on invert transformation, and now we have the wood planks fractured like wood fracture. I'm going to set this to 0.05. The smaller the value, the more elongated the pieces are, which is cool. So let's do visualize pieces, and that's our wood fracturing. The only tricky part is if you have a lot of wood planks and stuff like that, you have to find an angle that you can transform them along, which can be a very challenging problem. If they're aligned to one axis, you can compute the bounding box and find out which one, what direction they're pointing at, based on the maximum bounding box value, if it's the X or Y or Z that has the highest value, and then group them from there. Cool. So this is for wood fracturing, and then I'm gonna go back to which part? This guy? Yeah, let's do this guy. So here I want to do the high-res version. Now it's very, very important that we do this after the name attribute, because we're going to create a copy of all this with a high-res interior that we can use with the transform pieces. Okay, so instead of using the one with the low-res interiors, we can use the one with a high-res interior. So let's do an object merge and do it in a separate section. Okay, let's move here. And I'm gonna blast the inside and the outside. So this is the outside. Let's copy this. Delete non-selected, and these are our interior faces. Now it's going to be tricky for these guys, but hopefully we'll get it to work. Okay, so the first thing is to add more details to this. I'm gonna use a divide node and just use the breaker the breaker polygons. I'm gonna copy paste relative values on these guys. So we just have to change one value. Set this to 0.2. And again, doing a division on all of them is much faster than doing it individually or in the Varnai node. So let's start with 0.4 and then we'll go from there. Now the first thing we want to do is we want to add the noise to this. So let's copy the same node we used to do the deformation. So just a simple noise here. Okay, and the main once we do this, the main issue is we need to keep that edge. We don't want to deform the edge itself. Okay, and what I'm going to do, let's put this aside. I'm going to use a group node. Okay, I'm going to group include by edges, uncharted edges. And I'm going to group points, and this way it's going to group all the edges, all the points that are at the boundaries of all of this. Let's create a color node. I'm going to set all the colors to black, and then only I'm going to set the color red on edge points. And now we've colored these guys only, but the result is not it's 1 or 0 right now, and I want to smooth that out. I want to have a nice fall off between the edges and the center. So we're going to use a smooth node, and this can smooth any attribute on the mesh. I'm going to smooth the color attribute. Okay, I'm going to set the strength to 20 and the filter quality to 1. And see, now we have this nice gradient from the center all the way to the edges. We're going to use this information as a mask so that we only affect the center. The value in the viewport may not represent the correct, may look like there is no information here, but actually there is, so we're going to be affecting the center only. Let's go back and plug this this node, and I'm going to dive inside. And let's set the color to be white so it's easy to see. Float is fine. And then we're going to mix between the new position and the old position using the color information. So vector to float, I want to get the red channel and use that. Okay, so go back up and increase this. And you can see the edge is not changing at all. Only the interior. Is it? Yeah, only the interior. You can see it working. So let's lower the frequency here. Something like that. Let's add a facet node. I want to look at this with proper normals, so we know what we're looking at. Cool, so I think it's working. We can add some details. Let's set this to 0.2. From the whole graph, this is the slowest part that we have to deal with. Yep, so we have very cool interior. Okay, let's merge this back with the outer layer, and let's take a look at this flat shaded. And an easy way to check this is using a color node and set this to red, and see we're still getting a lot of that bleeding out, and we want to fix that. And the easiest way to do that is using volumes. So what I'm going to do is I'm going to use a fuse node, and I'm going to fuse all these, everything here. Okay, and then I'm going to create a VDB from Polygon and convert this into an SDF. Let's make sure it's quite high res, because we want to capture all the details. Okay, that's too much. And then we're going to let's do this. I'm going to store the rest attribute, which is to store the original position. Okay, and then I'm going to create a point pop. I don't need the color at this point. I'm going to connect the volume in the second input. I'm going to do a volume sample. I'm going to connect the position, and the geometry is coming from the file, or let's do a second input. And let's connect this to the color. Now see, some parts are gray, they're not black, and those are the guys we want to push back in. But I don't want it to, I wanted to do it here. So with the volume sample, it's returning either 1 or -1 if it's inside or outside the volume. And I'm going to use a compare node, and if the result is higher or equal than 0, use a different color, otherwise use another color. So two-way switch. I'm going to create a constant, red here, and green, and let's connect this. Cool. So see, everything inside is blue, everything outside is red, and we have that rest attribute. So I'm going to use a bind node and import the rest attribute. I'm going to mix between the deformed mesh, the original one that doesn't have any distortion, and I'm going to use this guy as the controller. Let's do a vector to float. I'm going to just grab the red channel because those guys are red. So if we do this, that's the white mask. Let's connect that here, connect it here, and boom, you saw them already snapped into position. Let's turn this off. See, they're outside and then inside. Cool. And let's merge this back with the outer layer and see how it looks. Cool. So it's definitely much better. It's gonna look better in the render as well. We can add a small amount of peak onto the outer layer geometry, or peak the interior geometry just a tiny bit. Yeah, something like that. And this is most likely a viewport display because it cannot order them by depth as good as the render does. Okay, let's give this a more interesting color, brown. And now I'm going to create an object merge. Let's copy this. I'm going to go back all the way here, and I'm going to copy this merge. I'm going to leave all these guys because we didn't change them, and just swap that high res with this. Everything should stay the same. Everything should behave in the same way. let's do an object merge and grab this merge 11, and I'm gonna move this all the way here. Where is it? This guy. And this is our low res version, and this is with the high res interior. Let's play it. Obviously it's not working. The reason for that is because we need to do this copying again. So I'm gonna copy this. It needs to be packed, and that's it. So I'm gonna copy this section here, and let's disable this guy, and let's assemble the geometry. Let's copy this node as well. Out RBD high res. Okay, hopefully this has everything needed. In theory, it should work even with one block, because the name is all that matters, but it's fine. So it's running the sim again. It's using the original data for the sim. Almost there. Yep. We are done. That's our interior surfaces, high res and ready to rock and roll. See, when I lowered the anti-aliasing to 8 in the viewport from 8 to 4, it showed up a little bit of flickering, and I'm pretty sure in the render this should be fine. And yep, we have cool high-res details, and the sim is very light, the workflow is very light. All the renders should not have any issues dealing with this, and it will be much faster than doing it at render time and having to deal with UVs. I actually now forgot to talk about the UVs. With this workflow, we don't lose any UVs, so everything will stay the same. You don't lose any attributes, UVs, or anything else because of the distortion, and your sim is actually very accurate. You can use this. We can use this to do the high-res emission of smoke, particle interaction, everything we need to, and it should work perfectly. Cool. Thank you guys for watching, and see you in the next video. Bye bye.